A secondary tap box serves as a distribution point for secondary conductors, especially when existing equipment lacks sufficient capacity. Several manufacturers produce these tap boxes, including Eaton's Cutler Hammer with their tap boxes and pad-mounted tap boxes, Siemens with their secondary tap boxes, GE with their secondary service tap boxes, Cooper Power with their tap boxes, and ABB with their secondary service tap boxes. These boxes provide a convenient and safe way to extend secondary services. The conductors connecting the transformer to the secondary tap box must be protected from overcurrents. This protection is essential to prevent damage and hazards in the event of a fault. Several methods can be employed to achieve this protection. Firstly, fuses. Current-limiting fuses can be installed at the transformer or in a separate fuse enclosure. These fuses are designed to quickly interrupt the circuit when an overcurrent occurs, limiting the amount of energy that flows through the conductors. Secondly, circuit breakers. A circuit breaker can be installed in the secondary tap box or in a separate enclosure. Like fuses, circuit breakers are designed to trip and open the circuit under overcurrent conditions, providing reliable protection. Thirdly, overcurrent protection device within the transformer. Some transformers are equipped with an internal overcurrent protection device that safeguards the conductors connected to it. This internal protection can simplify the installation and ensure coordinated protection. Additional considerations are vital for ensuring a safe and effective installation. The size and capacity of the secondary tap box must be appropriate for the number and size of conductors being added. Selecting the correct size ensures that the tap box can handle the expected load without overheating or causing voltage drops. The tap box should be installed in an accessible location and properly grounded. Accessibility is crucial for maintenance and future modifications, while proper grounding is essential for safety and to prevent electrical shock hazards. Conductors from the transformer to the tap box should be routed in accordance with National Electrical Code requirements and should be sized to handle the expected load. Following NEC guidelines ensures that the installation meets safety standards and that the conductors are capable of carrying the necessary current without overheating. When choosing a secondary tap box, consider the specific requirements of the application, including the number of conductors, the load current, and the available space. Select a tap box that is appropriately rated for the voltage and current levels involved and that meets all applicable safety standards. Ensure that the tap box is installed in a location that is protected from physical damage and environmental factors such as moisture and corrosion. Regularly inspect the tap box and its connections to ensure that they are in good condition and free from corrosion. Tighten any loose connections and replace any damaged components promptly. If fuses are used, make sure they are of the correct type and rating for the application. Replace any blown fuses with fuses of the same type and rating. If circuit breakers are used, periodically test them to ensure that they are functioning correctly. Replace any circuit breakers that are not tripping properly. Always follow safe electrical work practices when working with secondary tap boxes and conductors. To energize the circuit before performing any work and use appropriate personal protective equipment such as gloves and eye protection. Consult with a qualified electrician if you have any questions or concerns about the installation or maintenance of secondary tap boxes. The selection of overcurrent protection devices should be based on a coordinated approach. Coordination studies help determine the appropriate size and type of overcurrent protection devices to ensure that they operate in a specific sequence during a fault condition. This helps to isolate the fault and minimize the impact on the rest of the electrical system. Conductors must be sized appropriately for the ampacity they will carry. The National Electrical Code provides guidance on conductor sizing based on the type of conductor, insulation, and installation method. Proper conductor sizing prevents overheating and voltage drops. Consider the ambient temperature when determining conductor ampacity. Higher ambient temperatures can reduce the ampacity of conductors, requiring larger conductors to be used. Ensure that all connections are made using appropriate connectors and are properly torqued. Loose or corroded connections can cause overheating and voltage drops. Grounding is critical for safety and to prevent electrical shock hazards. The grounding system should be properly installed and maintained in accordance with the National Electrical Code. Surge protection devices can help protect sensitive equipment from voltage surges caused by lightning or other electrical disturbances. Surge protection devices should be installed at the service entrance and at other critical locations in the electrical system. Regularly inspect the secondary tap box and its components to ensure that they are in good condition. Look for signs of corrosion, overheating, or physical damage. Perform infrared scans to detect hot spots, which can indicate loose connections or other problems. Develop a maintenance plan that includes regular inspections, testing, and cleaning of the secondary tap box and its components. Keep records of all maintenance activities. Before working on any electrical equipment, de-energize the circuit and verify that it is de-energized using a voltage tester. Follow lockout/tagout procedures to prevent accidental re-energization of the circuit. Wear appropriate personal protective equipment, including gloves, eye protection, and arc-rated clothing. Be aware of potential hazards, such as energized equipment, sharp objects, and confined spaces. Work safely and follow all applicable safety procedures. If you are not qualified to work on electrical equipment, hire a qualified electrician to perform the work. Secondary tap boxes are used in a variety of applications, including commercial buildings, industrial facilities, and residential complexes. They are commonly used to distribute power to multiple tenants or to provide separate services for different types of equipment. The National Electrical Code provides specific requirements for the installation and maintenance of secondary tap boxes. Familiarize yourself with these requirements to ensure that your installation is compliant and safe. Electrical codes and standards are constantly evolving. Stay up to date on the latest changes to ensure that your electrical systems are safe and compliant. Consider attending training courses or workshops to enhance your knowledge of electrical systems and safety practices. Electrical safety is a shared responsibility. By following safe work practices and maintaining your electrical systems properly, you can help prevent accidents and injuries. The proper installation and maintenance of secondary tap boxes are essential for ensuring the safety and reliability of electrical systems. By following the guidelines and recommendations outlined, you can help prevent electrical hazards and ensure that your electrical systems operate efficiently and safely. The NEC mandates that all electrical work be performed in a neat and workmanlike manner. This includes proper routing and support of conductors, secure connections, and clear labeling. Always use appropriate tools and equipment for the job. Using the wrong tools can damage equipment and create safety hazards. Never work on energized equipment unless it is absolutely necessary. If you must work on energized equipment, follow strict safety procedures and use appropriate personal protective equipment. Be aware of the potential for arc flash, which is a dangerous electrical explosion that can cause serious burns and injuries. Wear arc-rated clothing and use arc flash protection devices when working on or near energized equipment. If you are working in a confined space, follow confined space entry procedures to ensure that the space is safe to enter. Never assume that a circuit is de-energized. Always test the circuit with a voltage tester before working on it. Use a ground fault circuit interrupter for all temporary wiring and portable equipment used in wet or damp locations. Keep electrical panels and equipment clear of obstructions to allow for easy access and ventilation. Never overload electrical circuits. Overloading circuits can cause overheating and fires. Replace any damaged or worn electrical components promptly. Damaged components can create safety hazards. Educate yourself and others about electrical safety. The more you know about electrical safety, the better you can protect yourself and others from electrical hazards. By following these additional tips, you can help create a safer electrical environment. In summary, when dealing with secondary tap boxes, remember to identify appropriate manufacturers like Eaton, Siemens, Cooper Power, and AB. Ensure proper overcurrent protection using fuses, circuit breakers, or transformer octs. Pay attention to key considerations such as tap box sizing, accessibility, grounding, and adherence to national electrical code requirements. Continuously stay informed and updated on electrical safety practices and regulations. Remember, safety is paramount when working with electrical systems.